Hi everyone, so I'm going to be doing another AP Physics C free response. This one is from 2003 and it's ENM2. Okay, in the library you connect a resistor and a capacitor with unknown values in series with a battery of M equals 12 volts. You include a switch in the circuit. When the switch is closed, time t equals 0, the circuit is completed and you measure the current through the resistor as a function of time as plotted below. The graph I just redrew here, it's current versus time, and you can see that it starts at 0.010 and then it just becomes asymptotic to 0. And the formula they give us, a data fitting program finds that the current decays according to the equation I equals m/r times e to the negative t over 4. Okay, so part A. Using common symbols for the battery, the resistor, the capacitor, and the switch, draw the circuit that you constructed. Show the circuit before the switch is closed and include whatever other devices you need to measure the current through the resistor to obtain the above plot. Label each component in your diagram. For part A, they want to know what the circuit would basically look like. So first off, we can start with our nth, which we could draw right here. And now they tell us that it's connected in series with the resistor. So we can draw our resistor right here. Also, they say that the capacitor is also in series and there's a switch included. But using this, we know that initially when the switch was open, there was 0.01 current, and then when the switch is closed, the current became usually less. That means the current is also going through something else. So we want to have the switch before the capacitor. So switch. And then the capacitor is in series, so we can draw it right here. And we want to measure the current through the resistor to obtain the plot. So we'll include an ammeter right here after the capacitor in series with it. Oh, sorry, that's not really visible. Okay, well, this is a capacitor. Because for an ammeter to measure resistance, you'd want to have it at 0 resistance in series. Okay, so that's what it would look like. Now part B. Having obtained the curve shown above, determine the value of the resistor that you placed in this current circuit. Okay, so we can do this by using the equation they gave us, which is right here. So I'll just copy it. So we have I equals E over R times e to the negative t over 4. Okay, so if we plug in values, we can see that the current at t equals 0 is 0.010. That is a full current going through the circuit. So we can plug that in. So we have I equals 0.010 equals nth over resistance times E. And since t is 0 and e to the 0 is 1, this entire term cancels. So we have that the resistance equals nth over 0.010 amps, and the amp they told us is equal to 12. So we'd have 12 volts over 0.010 amps equals 1200 ohms. So that's the value of the resistor. Okay, so part C. What capacitance did you insert in the circuit to give you the result above? Okay, so now they want to know the value of the capacitance. If you look at this equation right here, you realize that this equation is the same exact thing as that of a discharging capacitor. So basically, discharging capacitor, you have the formula I equals I initial times e to the negative t over 4. Well, if you use V equals IR, I equals V over R, which is exactly what's here, the amp over the resistance. So basically, in that formula, the T, this is the time, and then this over here is a time constant. So we have that the time constant, or test, equals R times C, and that we know by this equation equals 4 seconds. So to solve for C, we just have to change around the equation. So we have C equals 4 seconds over R, and we discovered above that R is 1200, so 4 seconds over 1200 ohms, which equals 3.33 times 10 to the negative 3 farads. Alright, and that's basically it. That's how you would do this equation, this problem, and I hope it helped. Okay, bye.